Welcome to BIM and AI in Practice. We're thrilled to have you with us for the premiere episode of our Autodesk Revit 2025 Tips series. In today's session, we'll dive deep into the Architecture tab, the central hub for accessing essential architectural tools, including doors, windows, stairs, and much more. But that's just the start. We'll also explore other critical areas for architects, such as the Massing and Site tab, where you can access powerful tools for conceptual design, massing studies, and site development. This tab provides you with essential site design tools, including the creation of toposolids and other key site features. This session is perfect for both beginners and intermediate users, though even advanced professionals will find valuable tips to optimize their workflows. For our engineers and construction professionals, stay tuned. We've got dedicated videos coming soon on the Structure tab, where you'll learn how to work with tools for structural design, connections, foundations, reinforcement, and much more. We'll also be covering the Steel tab, Precast tools, Analyze tab, and collaboration features, giving you the tools to enhance your engineering and construction workflows. Be sure to check back each week for new, in-depth content that will help you unlock the full power of Autodesk Revit and elevate your BIM experience. Let's jump right in. The ribbon is your central workspace in Autodesk Revit, offering quick access to all the essential tools you need to design your project or family. It's organized into several key tabs, such as Architecture, Structure, Insert, Annotate, View, and more, each focused on specific aspects of your design process. Within each tab, you'll find panels organized from left to right. The most frequently used tools are positioned in the leftmost sections for easy, efficient access, ensuring that you can stay productive and streamlined as you work. Many of the controls and tools you'll use to modify elements in the drawing area are only available when an element is selected. To make selection easier, Autodesk Revit includes an automatic highlighting feature. As you hover your cursor over elements, Revit will visually highlight them to help you identify what's available for selection. When you hover your cursor over a tool on the ribbon, Revit also displays a tooltip by default. This brief description provides essential details about the tool's function. If you need more in-depth information, simply press F1 while the tooltip is visible to open the relevant help documentation. Now, let's take a closer look at the tools available in the Architecture tab. This tab provides access to a wide range of essential architectural tools, including those for designing doors, windows, stairs, rooms, and areas. After opening a floor plan or 3D view, click the Architecture tab, then navigate to the Build panel and select the Wall drop-down menu. Here you'll find several options, including Wall, Architectural, Structural Wall, and Wall by Face, which allows you to create a wall from a mass face. Once you've placed a wall in your drawing, you can enhance it by adding sweeps or reveals, editing the wall's profile, and inserting hosted components like doors and windows. If you'd like to adjust or even disable the tooltips, head to the File tab, select Options, and navigate to the User Interface tab. There, you'll find Tooltip Assistance, where you can customize the behavior of tooltips, whether that's adjusting their settings or turning them off completely. Like other fundamental elements in a building model, walls are instances of predefined system family types, each representing standard variations in wall function, composition, and thickness. You can easily customize these characteristics by modifying a wall's type properties. This allows you to add or remove layers, divide walls into regions, adjust their thickness, or change the assigned material. You can add walls to your building model by selecting the Wall tool and placing instances of the chosen wall type in either a plan view or 3D view. If you want to use a different wall type than the one currently displayed in the type selector, simply choose a new type from the drop-down menu. Before placing instances, you can also modify certain instance properties for the selected wall type. Just use the lower section of the Properties palette to make adjustments. On the Options bar, you can specify several settings for your wall. Level. Go to your 3D views and select a level for the wall's base constraint. Height. Choose a level for the wall's top constraint. Or enter a value if you prefer the default unconnected setting. Location line. Select which vertical plane of the wall you want to align with as you draw. You can also align it with the line or face you choose in the drawing area. Regardless of the wall type, you can select any of the following planes, either from the Options bar before placing the wall, or the Properties palette. Before or after placing, Wall Centerline Default, Core Centerline, Finish Face Exterior, Finish Face Interior, Core Face Exterior, Core Face Interior. You can use the spacebar or on-screen flip controls to switch the interior-exterior orientation of the wall. Keep in mind that the location line is the axis around which the wall flips. Other options include Chain. The Chain option allows you to draw a series of connected wall segments, where each segment is linked at its endpoints to form a continuous chain. This option is useful for creating walls or boundaries that follow a specific path, with each segment connecting to the next. Alternatively, you can uncheck this option to draw individual, unconnected wall segments. Offset. Optionally, enter a distance to specify how far the wall's location line will be offset from the cursor position or from a selected line or face. In Revit, the Join Status option determines how walls intersect. When set to Allow, Revit automatically creates a butt join where the walls meet. If set to Disallow, walls will not automatically join, giving you control to manually manage how they connect. This setting helps you decide whether to streamline the intersection or customize it based on your design needs. To sketch a structural wall in your building model, use the Structural Wall tool. On the ribbon, go to the Structure tab, click the Wall drop-down, and select Wall Structural. Alternatively, you can find the same function under the Architecture tab. Wall drop-down and select Wall Structural. In Revit, the structural usage property for walls within the basic wall family defines the wall's structural function. It has 4 options. Non-bearing. The wall doesn't carry any loads other than its own weight. Bearing. The wall supports vertical loads, such as from floors or roofs. Shear. The wall resists lateral forces like wind or earthquake loads. Structural combined. The wall is both bearing and shear, supporting both vertical and horizontal loads. This property can be set in the Properties palette for each wall. It also impacts wall visibility, scheduling, and structural analysis in Revit. The third type of wall allows you to create walls from mass instances by selecting lines or faces using the Wall by Face tool. This tool places walls on non-horizontal faces of a mass instance or a generic model. To create a wall from mass faces, first open a view that displays the mass. Then go to the Massing and Site tab. and select Wall by Face. In the Type selector, choose the desired wall type. On the Options bar, specify the values for level, height, and location line. Next, move your cursor over a face to highlight it. Click to select the face, and the wall will be created. You can use the Sweep tool to add decorative horizontal or vertical projections to a wall, such as baseboards, crown molding, or other architectural features. This tool allows you to create custom profiles that follow a defined path along the surface, adding elegant details to your design. First, open a 3D view or elevation view containing the wall where you want to add the sweep. From the Wall drop-down list, select Wall Sweep. In the Type selector, choose the desired type of wall sweep. Next, in the Placement panel, select the orientation for the wall sweep, horizontal or vertical. Move your cursor over the wall to highlight the location for the sweep, then click to place it. Similarly, you can use the Reveal tool to add decorative horizontal or vertical cutouts to a wall, either in an elevation or 3D view. This tool enables you to create subtle, visually appealing openings or recesses, enhancing the design and aesthetic of the wall surface. If you have any special Revit tips or techniques to share, we'd love to hear them in the comments. If you found our content helpful, consider subscribing to stay updated. Your support means a lot to the team at BIM and AI in Practice. In your building model, use the Door tool to place doors in the walls, connecting and defining spaces. Each door not only offers access, but shapes the flow and experience of the design. When you place a door, an opening is automatically cut into the wall to accommodate it. Doors are hosted components, meaning you can add them to any type of wall. You can place doors in plan, section, elevation, or 3D views. To begin, click the Door tool. If you want to place a door type other than the one shown in the Type selector, simply choose a different type from the drop-down menu. To load additional door types from the Revit library, go to the Mode panel and select Load Family. Navigate to the Doors folder and open the desired family file. If you'd like to automatically tag doors as you place them, check the Tag on Placement option. To include a leader line between the tag and the door, select Leader. You can also enter a custom value in the text box next to the Leader checkbox. Place a door in your working area. Windows are essential for bringing natural light, fresh air, and ventilation into a space. They also contribute to energy efficiency by regulating temperature and reducing the need for artificial lighting. In Revit, you can add a window to any type of wall or place a skylight in an in-place roof. Similar to placing doors, click on the Window tool. If you want to use a window type other than the one displayed in the Type selector, select a different type from the drop-down menu. To load additional window types from the library, follow the same steps we covered for doors. Place a window in your working area. If you need to change the orientation of the window, select it and use the flip controls to adjust its position. Are used to model building elements that are typically delivered and installed on site, such as furniture and plumbing fixtures. You can place freestanding components in your building model by following these steps. On the ribbon, click one of the following. From the Architecture tab, in the Build panel, select Place a Component. From the Structure tab, in the Model panel, go to the Component drop-down and select Place a Component. From the Systems tab, in the Model panel, go to the Component drop-down and select Place a Component. For Revit users, it's important to understand the three types of families: system families, loadable families, and in-place families. Most of the elements you create in your projects are either system families or loadable families. System families are predefined in Revit, while loadable families are external files that you can load into your project. In-place families, on the other hand, are used to create non-standard or custom elements that are specific to your project. System families are used to create basic elements that would typically be assembled on a construction site. Examples include walls, roofs, and floors, ducts, pipes. System families are predefined in Revit. You don't need to load them into your projects from external files, nor do you save them outside of the project. Loadable families are used to create various building components and system elements, such as building components that are typically purchased, delivered, and installed, like windows, doors, casework, fixtures, furniture, and planting. System components such as boilers, water heaters, air handlers, and plumbing fixtures. Some annotation elements that are commonly customized, like symbols and title blocks. Unlike system families, loadable families are created in external RFA files and are imported or loaded into your projects. In-place elements are unique components that you create when you need something specific to the current project. Creating an in-place element involves many of the same tools in the family editor as creating a loadable family. Click on the Place a Component button. In the Type selector, at the top of the Properties palette, select the desired component type. If the desired component family hasn't been loaded into the project yet, click Load Family. Then, navigate to the appropriate category folder in the Load Families dialog. Select the family and click Open to add it to the Type selector. Creating an in-place element involves using many of the same family editor tools you use to create a loadable family. For more information on creating families, be sure to check out our other videos. In-place elements are custom components that you create directly within the context of your project. You should create an in-place element when your project requires unique geometry that won't be reused, or geometry that needs to maintain specific relationships to other project elements. While you can transfer or copy in-place elements between projects, it's best to do so only when absolutely necessary, as in-place elements can increase file size and impact software performance. In the Family Category and Parameters dialog, select a category for the element, then click OK. The category you choose will determine where the family for the in-place element will appear in the project browser, how it will be scheduled, and how you can control its visibility. In the Name dialog, enter a name for the element and click OK. The Family Editor will open. Use the Family Editor tools to create the in-place element. Extrusions, solid or void. Creating a solid or void extrusion is one of the most straightforward modeling techniques in Revit. To begin, you simply sketch a 2D profile on a work plane and then extrude that shape perpendicular to the plane. This process allows you to create complex 3D forms from simple 2D sketches, a key concept in parametric design where the geometry can be manipulated based on relationships defined within the software. The Blend tool. The Blend tool enables you to seamlessly transition between two different profiles or boundaries. For example, if you sketch a larger rectangle and place a smaller rectangle above it, Revit will automatically blend the two shapes together. This is especially useful for creating tapered or sloped forms, which are common in architectural and structural design. Revolve. A revolve creates a 3D shape by rotating a 2D profile around a specified axis. The shape can revolve through a full 360-degree circle or a portion of it, depending on your needs. If the axis intersects the profile, the resulting form will be a solid. Revolving a profile is a powerful tool for generating circular or cylindrical forms, essential for creating elements like columns or round features. Sweep form. A sweep form is generated by defining a path and a 2D profile, where the profile is guided along the path to create a 3D shape. Think of it as sweeping a 2D object along a curve, enabling you to create complex forms like molding or ductwork. This tool is vital for creating elements that follow a precise trajectory, such as railings or piping. Swept Blend tool. The Swept Blend tool takes the concept of the sweep and combines it with the flexibility of blending two distinct profiles. The resulting shape follows a specified 2D path, and the profiles can either be sketched or loaded into Revit. This tool is ideal for more complex geometries, allowing you to transition between profiles along a path, giving you greater control over form creation. Once you're done, click Finish Model to complete the process. Columns are essential in architecture and engineering, providing support and stability by transferring loads from the upper structure to the foundation. Beyond their functional role, they also enhance a building's design and appearance. Well-designed columns ensure safety, durability, and long-term structural integrity. Use architectural columns to model column boxouts around structural columns or for decorative applications. You can add columns in both plan views and 3D views. The height of the column is determined by the base level and top level properties, along with any offsets. To begin, click the column dropdown and select Column Architectural. On the options bar, specify the following settings. Rotate after placement. Select this option if you want the column to rotate immediately after placing it. Height. This setting will draw the column upward from its base. If you want to draw the column downward from its base, select Depth instead. Level unconnected. Choose a level for the top of the column, or select Unconnected and specify the column height. Room bounding. Select this option to designate the column as room bounding before placing it. Next, click in the drawing area to place the column. If you need to move the column, simply select it and drag it to a new position. Use the structural column tools to add vertical, load-bearing elements to your building models. On the ribbon, go to the Structure tab. Structure panel. Alternatively, you can go to the Architecture tab, Column dropdown, and select Structural Column. While structural columns share many properties with architectural columns, they have additional properties defined by their configuration and industry standards, which result in different behaviors. Structural elements such as beams, braces, and isolated foundations connect to structural columns, but they do not join to architectural columns. Additionally, structural columns include an analytical model for data exchange. The roof protects a building from the weather, provides insulation, contributes to structural stability, and enhances its appearance. It also aids in water drainage and helps preserve the building's materials. Revit offers several methods for creating roofs. Choose the method that best suits your design needs. You can create a roof from a building footprint, as an extrusion, or from a mass instance. To create a roof using the building footprint, click Roof by Footprint. If you attempt to add a roof on the lowest level, Revit will prompt you to move it to a higher level. If you choose not to move it, Revit will notify you later if the roof is too low. On the Draw panel, select a sketch or pick tool. To edit the roof properties, use the Properties palette. When using pick walls, you can specify the overhang before sketching the roof. On the Options bar, select Extend to Wall Core if you want the overhang to be measured from the core of the wall, then specify the desired overhang value. Next, define the slope by selecting Slope-Defining Lines. To change the slope definition, select the line. Go to the Properties palette and click Defines Roof Slope. You can then adjust the slope value. Once finished, click Finish Edit Mode, and then open a 3D view to see your roof. To create a roof by extruding a profile, start by displaying an elevation 3D or section view. Then specify the work plane. In the Roof Reference Level and Offset dialog, select a value for the level. Next, sketch the roof profile as an open loop. Once you're done, click Finish Edit Mode. To create roofs on non-vertical faces of a mass, use the Roof by Face tool. First, open a view that displays the mass. In the Type selector, choose the desired roof type. Move the cursor to highlight a face. Then click to select it. Click OK to create the roof. Optionally, to create a roof from mass faces, go to the Massing and Site tab. Model by Face panel and select Roof by Face. Ceilings in architecture provide overhead support and help define a space's character. They also play a key role in insulation, acoustics, and lighting, enhancing both functionality and visual appeal. Use the Ceiling tool to create a ceiling at a specified distance above its level. To place a ceiling, click within the walls that form a closed loop or sketch its boundaries. Ceilings are typically created in a reflected ceiling plan view. Ceilings are level-based elements, meaning you place them at a specified distance above the level they belong to. For example, if you create a ceiling on level 1, it may be placed 3 meters above that level. You can adjust this offset in the Ceiling Type properties. To create floors, define their boundaries by either picking walls or using drawing tools. Floors are offset downward from the level on which they are sketched. Start by clicking Floor Architectural. Next, draw the floor boundaries using one of the following methods. Pick walls. By default, pick walls is active. Simply select walls in the drawing area to use as the floor boundaries. Sketch boundaries. To sketch the floor profile, select a sketching tool and define the boundaries manually. The floor boundary must be a closed loop. To create an opening in the floor, simply sketch another closed loop where you want the opening to appear. Click OK when you finish. You create structural floors by defining their boundaries, either by picking walls or using drawing tools. Adding structural floors to the building model is similar to creating regular floors. This includes tools for creating and editing slab edges, thickened slabs, drop panels, and ramps. You can also create custom structural floor types. You can create building elements from the faces of mass instances, generic models, imported solids, and polymeshes. To create floors from a mass instance, use the Floor by Face tool or the Floor tool. During conceptual design, use mass floors to divide a mass for analysis. Mass floors provide geometric data about the dimensions of the mass above the slice, up to the next slice or the top of the mass. Use the Floor by Face tool. You can create a mass floor at each level defined in the project. These mass floors display graphically as a slice through the mass at a specific level. To add slab edges, select the horizontal edges of floors. You can place slab edges in 2D views, such as plan or section views, or in 3D views. Highlight the horizontal edges of the floors and click to place a slab edge. You can continue an existing slab edge around a floor or remove segments from an existing slab edge. To do this, click Modify, then select Add Remove Segments. Click the edges to add or remove segments of the floor slab edge. A curtain system refers to a non-structural, lightweight exterior wall system, typically made of glass, metal, or other materials, that is hung from a building's frame to provide weather protection and aesthetic appeal. It allows for large windows or open spaces while maintaining the integrity of the building's structure. A curtain system is a component that includes panels, curtain grids, and mullions, and it typically doesn't have a rectangular shape. To create a curtain system from mass faces, use the Curtain System by Face tool. First, open a view that displays the mass. Then, click the Massing and Site tab and select Curtain System by Face. In the Type selector, choose a curtain system type that includes a curtain grid layout. Move the cursor to highlight a face. Then click to select it. If the Select Multiple option is cleared, the curtain system will be placed on the face immediately. If Select Multiple is enabled, select additional mass faces by clicking an unselected face to add it, or click a selected face to remove it. The cursor will indicate whether you're adding plus or removing a face. Once the desired faces are selected, click Create Curtain System. You can use curtain element tools to design building facades, including curtain walls, curtain grids, mullions, and curtain systems to achieve the desired aesthetic. After creating a curtain wall, use grids to divide the wall into panels. For curtain walls with regular patterns, the curtain grids are most easily defined through the type properties of the curtain wall. You can edit the type property for the pattern, which will automatically update the curtain wall with grids and mullions. For irregular patterns, you will need to manually place the curtain grids. You can place both regular and irregular curtain grids on a wall. Customize the curtain grid, place mullions on grid lines, and embed doors or windows within curtain panels. In this example, we'll transform a regular curtain wall into one with an irregular pattern. First, select the wall and isolate it in the canvas using the glasses icon on the View control bar. This will make it easier to see the changes as you make them. Click Curtain Grid. From the Placement panel, select a placement type. Place the cursor along the wall edges. A temporary grid line will appear. Click to place the grid lines. Add additional grid lines if needed, or click Modify to exit the tool. After creating a curtain grid, you can place mullions on the grid lines. Remember, when you add mullions, they automatically resize to fit the grid. If you add a mullion to an inside grid, it will be centered on the grid. If you add a mullion to a perimeter grid, the mullion will align so its border is flush with the outside of the wall. Click Mullion and select the desired mullion type in the Type selector. In the Modify panel, select one of the following tools. Grid Line. Click a grid line in the drawing area, and this tool places a mullion across the entire grid line. Grid Line Segment. Click a grid line in the drawing area, and this tool places a mullion on the individual segment of the grid line that you click. All grid lines. Click any grid line in the drawing area, and this tool places mullions on all grid lines. When you finish placing the mullions, exit the tool. A ramp is an inclined surface or pathway that provides a gradual transition between different levels, making it easier for people to move between areas, especially for those with mobility impairments. It is commonly used in places like entrances, parking lots, and public buildings to ensure accessibility. To create a ramp in either a plan or 3D view, you can sketch the ramp's run or define its boundary lines. The simplest way to add a ramp is by sketching a run. However, the Run tool limits your design to straight runs with landings, and spiral ramps. For more flexibility in designing ramps, use the Boundary and Riser tools to sketch the ramp's run. Open a plan or 3D view and click Ramp. In the Modify tab, select either line or center ends arc for your ramp's shape. Note: the default settings for top level and top offset may result in a ramp that is too long. You can adjust the top level to the current level and reduce the top offset for a better fit. Place the cursor in the drawing area and drag to sketch the ramp's run. Once you're happy with the design, click Finish Edit Mode to complete the ramp creation. A railing is a barrier or support structure placed along the edge of a staircase, balcony, or walkway to enhance safety and prevent falls. It is designed to provide both functional support and aesthetic appeal. To create a railing, start by sketching the railing path and selecting an element to host the railing, such as a floor or roof. The shapes of the rails and balusters are defined by the profile families loaded into the project. Click Sketch Path from the Railing dropdown. Next, to set the host for the railing, click Pick New Host. Place your cursor near the host. This could be a floor, roof, wall top, staircase, or topographic surface. As you move the cursor, the appropriate hosts will highlight. Click on the host to select it. Now, you can proceed to sketch the railing along the desired path. If you didn't add a railing when creating a stair or ramp, you can easily add one afterwards. Click Place on Host. In the Type selector, choose the type of railing you want to place. Then, select the host component in the drawing area to attach the railing. A stair is a set of steps or a flight of steps designed to connect different levels of a building or structure, allowing people to move vertically between floors. Stairs typically consist of treads, the horizontal surfaces, and risers, the vertical sections between treads. To create a stair, you'll assemble components for common runs, landings, and supports. You can create straight stair runs and let Revit automatically generate landings to connect each run. Start by clicking Stair. On the Components panel, make sure Run is selected and that the Straight tool is active. Use the Type selector to choose the type of stair you want to create. If needed, you can always change the stair type later. In the Options bar, select your preferred option for the location line. Set the run width and ensure that automatic landing is checked. Click to specify the start of the first run. As you draw, the boundary of the run displays, showing the steps required to reach the target level or elevation. Click again to set the end of the run. Next, click to define the starting and ending points for the second run. In the 3D view, you'll notice that landings connecting the runs are created automatically. To adjust the stair position, you can use standard editing tools like Move. On the Tools panel, click Railing. Here, you can select the railing type and decide whether to place the railing on the treads or the stringers. The railing will appear when you finish the stair. Additionally, you can customize how the stair is represented, including its symbolic representation, annotations, and graphic display. Learning is a continuous journey, and as you acquire more knowledge, you unlock the potential for greater creativity and idea generation. This process fuels innovation, allowing you to deepen your understanding. Similarly, in our exploration of Autodesk Revit 2025, the Architecture tab and its tools offer an exciting way to enhance your design process. That wraps up the first part of our deep dive into efficiently navigating and utilizing these tools. Thanks for tuning in to the first video in our Revit Tips series, and be sure to stay tuned for the next video, All Architecture Tab Tools, Part 2.